When you think of the word nuclear, what comes to mind? It's probably some terrifying thought. I can't blame anyone for being nervous. It's a technology that we've been using for decades that can really reduce global warming, but it's not exactly something environmentalists are that excited about.
The first thing many people think of is nuclear war and mushroom clouds. You add into that major events like 3 Mile Island and Chernobyl and most recently Fukushima, and those have had incredibly profound consequences on people's immediate feelings and images and associations with this technology.
This isn't something where the public has the view wrong. It is a technology with a reputation that's been earned. I mean, if a nuclear power plant was being built in my town, I'd be pretty nervous about it. However, as a conservationist, that makes me feel really conflicted because these power plants don't emit CO2, and that's the main pollutant that's causing climate change.
When you look at the technology and you ask yourself, how are we going to solve this problem of climate change? To not have nuclear energy be on the table makes the job much harder.
Now, for the most part, these plants work really well. They supply about 20% of the electricity on the US power grid. But almost all of them in the US were built over 35 years ago. In fact, they look like something out of a vintage movie set. And historically, they've had two big problems. They produce radioactive nuclear waste, and they can be vulnerable to a disaster like a nuclear meltdown. Leslie Dewan is trying to fix this. She runs a startup company called Trans-Atomic Power. They're trying to build new power plants without this problem.
Our reactors operate at atmospheric pressure, and you don't need that typical containment dome. You don't need the big stacks. You have a lot more flexibility in the architecture of the plant.
But it isn't just about stopping disasters. The fuel itself is toxic and has to be stored underground for thousands of years. And unfortunately, we don't use it very efficiently.
The solid fuel can only stay in the reactor for a limited amount of time before it starts to break itself down and you have to physically remove it.
But that's actually how older reactors use nuclear fuel. The next generation reactors are using fuel much more efficiently. Transatomic's reactor design will use fuel in a liquid form so that it can stay in the reactor for a longer period of time. There's a huge interest to phase out conventional fuel rods for different forms of fuel for a variety of reasons.
In the last 20 or 30 years, we've developed different types of fuel which cannot melt, and which in fact,
what do you mean by that?
Physically cannot melt.
That's Per Peterson. He's a nuclear engineer at the University of California, Berkeley, who's working on a next-generation reactor design that uses an entirely different form of fuel. Many older plants still use conventional fuel rods. This new design, known as a fuel pebble, encases uranium in a golf ball-sized sphere.
They're designed to be very safe. You can drop this thing from 10 meters onto a steel plate and it won't break. Or if I wanted to, I could drop it right now. And
so essentially, that fuel pebble is designed to be its own self-contained system. If a power failure does happen, the pebbles just empty into a holding tank where they cool down on their own. No need for backup generators or water to keep it cool to prevent a meltdown. Okay, so why hasn't this happened yet?
You know the old phrase, you never get a second chance to make a first impression. People's first impression of nuclear energy and nuclear power was mushroom clouds. And as it's got the word nuclear associated with it, it's just going to be very difficult to convince people, no, we mean it this time. This one's safe.
It puts nuclear energy in a very challenging place. Right now, even solar and wind are cheaper than nuclear power, so there isn't a lot of economic incentive to build these power plants. And if no one wants to build them, then companies that make the parts go out of business or go somewhere else where new plants are being built, like China.
Those that are under construction now, the economics have been really grim. The number of plants that have been started and the price overruns have been massive.
One of the problems is just simply transporting the components. Instead of getting the parts locally like we did in the 1960s and 70s, the parts today are shipped from overseas. And these aren't just basic nuts and bolts. These are huge, complicated components. If a section of a reactor vessel breaks during transport, it needs to be fixed, or a new one needs to be built and reshipped, taking more time and money to complete.
I think that it's going to be very interesting to see how startup companies tackle those problems. And this is a very different space from where the traditional technology evolved.
Now, rapid innovation has happened in other industries. Look at SpaceX, for example. They went from a concept rocket to delivering supplies to the International Space Station in a matter of years.
The technologies that are being researched now that look very promising range from small modular reactors, where the whole nuclear power plant comes in the back of a flatbed truck, gets parked, plugged in, and when the fuel is used up, simply gets taken away as a unit to be reprocessed.
These small modular reactors could have specific uses, like powering a data center that's using electricity around the clock. We have startups building cheaper, smaller reactors that don't melt down. We have engineers making fuel that doesn't produce much waste. While the public image of nuclear energy is rooted in the past, the nuclear energy of today is a whole different ballgame. There are other energy sources that we may be overlooking. Head over to climate.universityofcalifornia.edu for more.